Okay, so I'm going to provide some solutions to these questions. So first we have the sine of x is equal to negative 12 over 13, and x is in the fourth quadrant. That's Q4 right there. Determine the value of sine 2x. So what we're going to use to find sine 2x here is its definition, which is 2 sine x times cos x. So we already have sine x, it's right there. We just have to find cos x. And then we can just pop it into this equation and solve it. So doing this fairly quickly, our x value is in quadrant 4, so it's right over here. And this value all the way around here, oh, you can't see that. This value all the way around here is x. So we're just going to build our triangle, and we're going to have sine as opposite over hypotenuse. So it's going to be 12 over 13, which means this missing corner is going to be, so I'm going to punch into my calculator, 13 squared minus 12 squared is 25, which square rooted means that that missing side is 5. So let's just put this as A, I guess. And this is B, and this is C, excuse me, and this is B. So A squared plus B squared equals C squared gives us A squared plus 12 squared equals 13 squared. So A squared is equal to 169 minus 144. So A is root of 25, which is 5, which means that the cos of x, and it is a quadrant 4 answer for x, so it is positive, is going to be equal to 5 over 13. Now to find the value of sine 2x, we simply say 2 times negative 12 over 13 times 5 over 13 to give us negative 24 times 5, which is 120, negative 120 over 169. Okay, if you can reduce that, then reduce it. If you can't, then don't. Let's move on to the next one. So this one's a little trickier because we have the tan of x equals negative 1 over 13. I'm reading that correctly. So we're going to solve this as if it was just regular x to start. So it's going to say between 0 and 2 pi. Okay, sure, fine. So we are going to say, first and foremost, that that 2x, so the tan of 2x is equal to negative 13 over 5. So let me just double check one thing real quick. Okay, sorry about that. So for this one here, the tan of 2x is equal to negative 1 over 13. It's going to get a little wibbly-wobbly while we try and figure it out, but we have to remember, let's just treat this initially like this 2x was just one number, okay? So if that's the case, then the cast rule tells us the tan is going to be negative in quadrant 4 and quadrant 2, okay? So we're going to treat this like normal. We are going to say that 2x, so first we're going to find we're going to find it as if it was tan of alpha equals 1 over 13. So it's basically like our quadrant 1 answer. And so alpha is going to be equal to the inverse tan of 1 over 13. All right. And so that is inverse tan 1 over 13. Oh, here's what I'm punching into my calculator, by the way. Inverse tan 1 over 13 equals this really tiny number, 0.07677. The more decimals you can keep in this case, the better, really. So now we're going to actually create our quadrant 2 answers, our quadrant 2, and our quadrant 4 answer. So quadrant 2, 2x, right, because that's what it actually is going to be equal to pi minus that quadrant 1 answer, 0.07677, right? So we get pi minus that, 0.07677 is equal to that number. And then we're going to divide it in 2 to find x. So x will be equal to, divide that by 2, 1.53. There's one of our answers, 1.53. Okay, and now we're going to find the quadrant 4 answer, where 2x is going to be equal to 2 pi minus 0.07677. And 2 pi minus 0.07677 is that, which we will then divide in by 2 to find x. And we find that x is equal to 3.103. And that's two of our answers. Now, when we have 2x as a factor, we actually have to consider the fact that the period has been shortened, right? It's been shortened in half. So what we need to do for each one of these answers, these 2x answers, is add another period on to find where the second period answer lies. But because we divided everything by 2, we add on half the period. So we have another answer of, which is also in quadrant 2, of x equals 1.53 plus half pi. So 1.53 plus pi divided by 2 is equal to, well, that 3.10. That's interesting. And let me just check one more thing. Hang on. Oops. I actually just made a small mistake. It wasn't adding half the period. It was just adding on one more period to x, because x is what we're looking at over here. And this will still keep it within the first iteration. And so when we say 1.53 plus pi, we end up with our second answer, which is 4.67. The reason we're adding pi to that is simply because that is the period of tan. Okay? If it was a cos or sine that we were trying to find this one, we'd be adding 2 pi to that answer. Now, finally, we've got our last answer here, which is going to be x is equal to 3.103 plus pi, which gives us our final answer, 3.103 plus pi, which is 6.245. Okay, so there's 1, 2. So we've got our 2 regular answers and our 2, what happens if we go one more cycle answer, right? Because that cycle has been compressed. So within 0 to 2 pi, it actually will hit that goal twice. So we just have to add on. We're like, okay, well, here we found one answer. And then if we jump forward by the period, we're at the same point, which is this answer here. And if you notice, all of these numbers, all 4 of them, are less than 2 pi, which totally reinforces what we're doing. And one other thing you could do is take any of these 4 numbers and plug it back into the original equation. So that means double it, then take the tan of it, and you should get negative 1 over 13. Okay, sounds good to me. Now, I do believe the last question here is going to be, well, for this one, I'm just going to set it up for you. I think you already know how to do this because only these 2 are marked plus the one on the next page. But for this one here, we would simply factor out tan. We'd get tan x is equal to cosecant x minus 2 equals 0. So we just say, okay, where's tan x equal to 0? And where's cosecant of x minus 2 equal to 0? And so then we can say, well, cosecant of x is equal to 2, and that means that that's 1 over the sine of x is equal to 2, which means the sine of x is equal to 1/2. We flipped over both fractions here. So then you solve that one and that one. Pretty straightforward, I hope. Proving an identity, I can do that if you really want, but it'll have to be at another time because that might be a little bit lengthy. I would recommend starting with the definition of what sine x and cos x both are. That will probably lead us to something very satisfying. In fact, let's do it just to be fun. So the cos of 2x is going to be, let's do the sine squared minus cos squared version. And let me just double check that formula real quick. Cos of 2x. The double angle formula says that the cos of 2x is cos squared x minus sine squared x. So if I were to actually plug that in, cos squared of x minus the sine squared of x, and this is just the left side, and the sine of 2x is cos 2 sine x cos x, and that's plus 1 over here. Then what we can do is we can swap that 1 for cos squared plus sine squared. So we get cos squared minus sine squared plus cos squared plus sine squared. So the sine squareds go away. And we end up with 2 cos squared of x over 2 sine x cos x. And then the 2's cancel out. And then, oops, sorry, I'm going to maximize my window here. Oh, you couldn't see any of the stuff I was just writing. Here we go. Sorry about that. So, like, yeah, right, I replaced cos 2x with cos x minus sine, cos squared minus sine squared, the 1 with cos plus sine, and then the sines cancel each other out, leaving with cos squared plus cos squared So it's 2 cos squared. The 2's cancel out. Fantastic. This cos and one of the coses cancel out, leaving me with cos x over sine x, which is in fact equal to the cotan of x. Hooray! So that's an identity done. Let's do this last question now. Determine the exact value of the secant of 13 pi over 12. That is a fun question. Okay, there's a couple of ways of approaching this problem. I'm just going to pick one and hope for the best. And if it doesn't work out, I'll just have to re-record this video. So what we're going to do is we're going to apply the definition of secant. And we're going to remember that this lies in the third quadrant, right? It's just a little bit more than pi. Okay, so secant, as you remember, is 1 over cos of 13 pi over 12, right? That's what this is defined to be. So if we can find the exact value of the cos of 13 pi over 12, then we can just apply it pretty naturally. So this is going to require us to use the compound angle formulas, which I'm looking up right now. Compound angle formula. There we go. And the cos of a plus b, well, why am I even looking this up, right? So the cos is narcissistic, but does the opposite of what it should, right? So it always does itself twice. So we've got the cos of a plus b is going to be equal to the cos of a times the cos of b minus the sine of a times the sine of b. Okay, so all that's left is to write 13 pi over 12 as a plus b. So we could convert this to a radian, to a degree, and that might make it easier for us to break it down to those common increments of, do we have somewhere where it's 45 degrees or 30 degrees or 60 degrees? Because if we can express it as a sum of one of these guys over here, then it's a little bit easier on our lives. So we will do 13 pi over 12. That will be 13 pi over 12 multiplied by 180 over pi. The pi's cancel out, and I have 13 times 180 over 12. 13 times 180 divided by 12 is equal to 195, which makes sense, right? A little bit bigger than 180, so it's a third quadrant angle. So now if we can express this as the sum of these guys, then we're in pretty solid shape. So we can actually see here that this can be written as 45 plus 150. That's pretty doable, right? For 150 is going to be 30 degrees before. Yeah, okay, so that's fine, right? So if we look at our unit circle, right, this angle here is 150, so it's about 30 degrees back from pi, or from 180, bringing us to converting it back to radians would have been 5 pi over 6. You can double check that by just saying 150 over 180 pi times pi over 180. That's 5 pi over 6, and 45 is just 45. Okay, so those are pretty straightforward numbers. So let's convert them back into radians now. And again, your teacher doesn't have to see this step. You can just magically come up with a sum that sums to 13 pi plus 12, right? So this is going to be equal to 1 over cos of the 13 pi over 12, which is 1 over the cos of 5 pi over 6 plus pi over 4. That's that 45 degree angle that we had. Now we can just apply this identity. And once we're done figuring out that exact value, we just flip over that final fraction. So we're just going to be doing 1 over for every single step. It's going to be annoying, but that's okay because it will get us to the end. So this will be the cos of 5 pi over 6 times the cos of pi over 4 minus the sine of 5 pi over 6 times the sine of pi over 4. Fantastic. And so that's 1 over all of this. And so this becomes 1 over the cos of 5 pi over 6 is minus root 3 over 2 times the cos of pi over 4 is root 2 over 2 minus the sine of 5 pi over 6, which is half, positive half, times the sine of pi over 4, which is root 2 over 2. Now working this out, we get 1 over, and this becomes negative root 6 over 4 minus root 2 over 4. And so I'm just going to continue this over here. I know my columns are all messed up. I would take off all of my marks for this. So I'm going to put these together as one fraction because that's when I'm allowed to flip it over. So this becomes 1 over negative root 6 minus root 2 over 4. And to make it, like, because it's 1 divided by this, I can flip over the bottom fraction to get 4 over negative root 6 minus root 2. Usually we want to try and rationalize our denominators if we can. So let's start by factoring out, well, what we can do is we can factor out a negative root 2. Right? So we have 4 over negative root 2, which is root 3 plus 1 is what's left. And then we can multiply the top and bottom by root 2 over 2, which gives us 4 root 2 over, we can move the negative up also, root 2. So this last bit here depends on whether or not your teacher actually wants you to rationalize the denominator or if they're okay with you leaving your answer at this stage. That's a question to ask. These extra steps are just to get these roots out of the denominator. So if I do multiply root 2 over 2, so this becomes multiplied by root 2 over root 2, so that becomes just 2. And so that becomes 2. And I've got root 3 plus 1. And then the 2 and the 4 cancel to give us minus 2 root 2 over root 3 plus 1. And we can rationalize that as well by multiplying top and bottom by root 3 minus 1. Because when we multiply this times this, it becomes 3. That times that cancels with that times that, and then minus 1. So the denominator becomes just 3 minus 1, which is 2. And the numerator becomes negative 2 root 2 times root 3 minus 1. That one is kind of brutal, but there it is with a rationalized denominator. I think you'd probably get most of your marks if you stop somewhere back here. However, the general procedure is the same. You could even just like run that through there. That will work. Yeah, the other alternative, I think for this one, we could rationalize it by just multiplying straight by, like, again, maybe move the negative out. So it becomes negative 4 over positive root 6 minus root 2, and then multiply top and bottom by root 6 plus root 2. It's called the conjugate, root 6 plus root 2. And then root 6 times root 6 gives us just 6. Root 6 plus root 2 gives us plus root 6 root 2. Minus root 2 times root 6 is minus root 6 root 2. So these two cancel each other out, which is why this works. And then negative root 2 times positive root 2 is minus 2. So you see we got here 6 minus 4 in the bottom. And then the top, we have minus 4 times root 6 plus root 2. The only reason it looks different than this is because here we factored out the root 2 from these two, and it combined with that 2 there. Over here, we're going to end up with a numerator with 4 coefficient, and here we have going to have 4 in the denominator. Yeah, so like just like these two 2's, which I did not cancel out, boop, boop, they would cancel each other out, leaving me just something very simple. Okay, so I'm sorry that little last bit was confusing, but if you understand what to do with rationalizing denominators, then it should be straightforward. The general procedure for solving this again is just be like, okay, change it into angles, right? 13 pi over 2, and then try and use these numbers to sum to make it, ideally something two good angles that we can actually find on our unit circle. Once we split it, it's just applying the compound angle identities, simplifying to one fraction, then flipping that fraction over, which is what happened over here. Okay, so that's it. That's the practice test solutions. I hope that you got something out of this. Have a great day.